its simplest level, the battery storage for the grid is simply connecting batteries to the grid that charge and discharge whenever the grid requires it. And we use that to offset conventional thermal generation and to support as the grid develops more renewables. So there's a number of different battery technologies available at the moment. Lithium-ion is the most commercial at the moment. There's been a lot of development in the technology over the past decade, and that's what's allowed grid-scale battery storage to be possible. The batteries themselves are similar to the batteries that are in your mobile phone. They're built up into modules, and these are built up into racks, similar to racks in a data center. And then these racks are put into an enclosure to weatherproof them. To build a grid-scale battery storage, a number of these enclosures are put together and connected through a power conversion system, which allows these batteries to charge and discharge directly on the transmission network. Generally, on a shipping container size battery, you get about 5 megawatt hours of energy. So could be 5 megawatts for 1 hour or 1 megawatt for 5 hours. And to put that into perspective, I suppose 5 megawatt hours of energy would power about 10,000 Irish homes for an hour. The actual storage in the battery really depends on the battery chemistry you're using. So generally, for a grid-connected battery like we're using, it would be for hours up to a couple of days before you'd start to lose energy. And then depending on the use case, you'd select a different chemistry to go for longer or shorter durations. For domestic houses, you can install a small battery that will capture the energy from a rooftop solar system. For businesses, for large energy users, they install battery storage to provide backup power and to reduce their peak demand on the grid. And then for utilities like ESB, we install larger batteries. It's used to capture the off-peak wind and use that to power homes during the peak demand. So it's shifting the renewables from when it's not needed to when it is. The battery sits there and monitors the grid frequency, and as it detects an over or under frequency, it will react accordingly to stabilize the grid. At the moment, the Irish grid is limited to 65% SNSP, so that's the amount of renewable generation connected relative to the overall demand on the grid. And without technologies like battery storage to provide this grid stability, that limit will stay at 65%. The Irish government target for 2030 is to increase that to 95% to support the 2030 targets. To increase the amount of renewables on the grid, a technology like battery storage is required to maintain stability as thermal generation is switched off. In Ireland and everywhere, it's increasing, and battery technology is required to stabilise the grid and to capture that and use that renewable energy more efficiently. In the last decade, there's been a lot of development in battery technology, so the capacity, the lifetime, the speed of response of the batteries has increased dramatically over the past decade. So it's now useful for a grid, and now batteries have got to the point where they're competitive with thermal generation for deployment onto grids. At the moment, there's 21 megawatts of grid-connected storage in Ireland. There's 700 megawatts of projects in construction or pre-construction at the moment, and there's the same number of projects in various stages of development. There's a lot of growth coming in the market, and ESB has projects in all stages of development.